I have made changes. I have rebased it. Up to now, please let me know when it got disconnected. Okay. So what I have done is I have rebased uh, the particular branch slave 1 to main branch. So it rebased, and I was seeing on no folder structure. Later I made changes in master branch and slave branch, and now I have the branching structure. Okay, in interviews what you will be asked is, after rebase what will happen if you make any changes. It will show again the same folder structure from that point of the rebase. Is that clear? Please ask me if you have any doubts. Okay. Now what we will see is, okay, so what we will see is now how to use diff and how to use um, what I say reset command to revert your changes. So what I have done is now I will check this itself. I have added file G and I'll add some content to file G, and then I will commit to it and revert it. Okay. This is file G line 1. Okay. So now I added some content to file G. Now if you check the git status, file G is here. See here, there are two changes, reverting and discarding changes in working directory. Discarding changes in working directory means whatever I have done now will be removed. Let me um, do it again. -git will remove the changes whatever I have done on this file. Okay. If you check this file would be empty. Okay. See here. Now I am adding. This is file G line 1. So what we have done, my local changes got reverted. Okay. So what if I committed this file and later I thought that my code is wrong? Then I have to get back to my previous version, right? So I will add it first and then I'll commit and then I'll revert it. It is very important task. That is the main feature of any version control system, to revert the code if something wrong happened to that, or if it is not working, you have to revert it. Okay. Modified file G. Okay. Now there is no changes. I have committed everything. Okay. If you check the log, I see this is my latest revision. But I made some. Let me make another change on the same file. Okay. I'll use cat command. This is also to write content. 0txt. This is line 2. Okay. If you check cat, oh, sorry. I need to hit enter. Control Z, not C. Okay, I have modified this file. Okay. Now I will add it. Git commit -m added line 2. Okay. So if I check I have added file G at this commit, and one modification. I added one line at this commit and second line at this commit. So later, after some time, I thought that whatever code I have written at this point of time, at this commit, was wrong. So I have to remove this and get back to the same version here, right? So at that point of time, what I'll do is I will use git reset, okay, git reset, and hyphen soft, and my commit number is 97. Let me copy this. I want to get back to this position, okay. um, Copy this revision, paste, okay, and I have to give the sorry, yeah, paste. So there are two types of resets. One is soft and one is hard. Soft deletes the modifications done, deletes the modification done in already committed thing. Okay, if you use hard one, it will delete the changes in local copy as well. Okay, we will see both the examples. Now, what it is done is git reset soft this. So my changes will go back to my previous version. You got my point? So I'm doing nothing. I have made the changes at this commit. I have added second line. Okay. I thought that that is wrong. So I want the previous version. Normally in real-time scenario, you may add 100 lines. Okay. And you may have modified already written thing. Okay. Both the changes are committed, but it didn't work. So you have to revert it to previous version. So now what I'm doing is I'm reverting to this version, which has only one line. Okay, if you check git status, what it is saying, it is in staging area. Okay, if you check this, for example, cat, you have both the lines. Okay, I'm adding one more line, for example, this is line 3. Okay, now it has 3 lines. Now I'm going to commit. Now you see git status modified. So one change is in this staging area, which was the previous one, and the third line is in this. So you have to add this again and commit it. Sorry. Okay. So if you check git status, everything is committed. There is no change. Now we will see branching structure. Okay. Now I have added everything. Oh, where is the change? Okay. Actually, I have given that reverted and committed again, right? So it is showing the previous message. Now I want to revert this change back to here, okay. So now I'm going to do hard one. Now you see we have 3 lines here. Now I will do hard reset. Okay, earlier it was soft. Now I will do hard reset. Hard reset will remove local changes as well. Not only in the repository, it will remove local changes as well. Softing only deletes the changes which are committed to the repository, so that in your local copy you can edit or modify the changes, modify the code, and you can commit it again. But in this case, in hard one, you will lose local copy as well, so that you need to be more careful before running this. Okay. Now you see here, I have only one line. So all my changes, line 2 and line 3 got removed from my local copy as well. Okay. This comes in very rare cases, the hard reset, but you use more, in most of the cases you use only soft reset. You got my point, right? You are just reverting your changes back to here. That is how it works. Is that clear up to here, or do you have any doubts? Okay. Now we will see how to commit your code to your centralized repository. Whatever we are doing now is a local copy. Okay, local copy. Now what I am doing is my copy is in this place. Okay. Now we will check how to create centralized repository. I'm showing this. Showing this on the same machine because I don't have two servers. But normally, whatever I am doing now would be done in centralized repository. Now let me create a file directly again. Okay. Central.git, for example. Okay. This central.git is a centralized repository, for example. Okay, I don't have anything in here. So in order to create any centralized repository, you have to use this command. Git init is command to create repository, but for centralized repository, you have to use use an argument git bear. Okay, so my repository got created. This is centralized repository. Remember that git bear argument is for centralized repository. In order to push, let me go back to my master branch there in Git. Okay, my master branch. I have to push. Okay, I have to push. Normally, how I have to push? It gave me one URL. You saw that, right? Oh, I cleared it. Git home. Oh, centralized Git. Master. So what this will do is it pushes my master branch to centralized repository. Okay, this is my local copy. In SVN, what you have to do is you have to first create your centralized server and get the code from that server and then push your code to there. But it is not necessary to create your centralized repository before creating your local Git repositories. Okay, that is the advantage of Git. So that you can start working on your system before setting up any centralized Git repository. Okay, so be specific here. Using git init --- bear command, we created centralized repository at this location. Okay, on the same computer. Say for example, normally in your real-time scenario, you will have uh, a remote machine, remote Git centralized machine, where you connect that machine with your username and your IP colon. Okay, you know IP, right? Which has four numbers separated by dots. IP. Like this you will give. It will connect using SSH. But here I'm using the same repository on the local machine, so I don't need to give it. So if I hit enter, Oh, the program push is currently not installed. You can install it by typing this. Okay, I have to install some utilities to do that. Oh, sorry. I have to use this. That push is different. I have to use git in front of this. So see here what it is saying. Counting objects 25 done. Delta compression using 4 threads, up to 4 threads. Compressing objects 100%. So it will compress the data and pushes it to centralized repository. Okay. Writing objects, everything written. The total size is this. And in your real-time environment, don't expect this size. It will be in GBs or TBs. Okay. And this is the centralized repository. Let me go back to my central repository and check the branch. I have only one branch, whereas in my this location I have two branches, right? So I only pushed my master branch. Okay, this is how you push your data. Okay, so okay, think this way. You have all think this way, like you have three systems. In one system, you created master and slave branches like here. Okay, like here. And after that, you have another server called central gate. You have your centralized repository there, and a new person joined. For example. His name is Jay, and I have nothing. I have nothing here. So I have to work. I have to work. I have to get all the code already existed in centralized repository, and I have to start working, adding my code to that particular thing. So in that case, what you will do is you will um, you have to clone that particular code repository to your local machine. This is the actual checkout happening in um, your SVN repository. But in Git, you have to use the clone command. So in clone, have this centralized repository, okay, to here. Centralized repository to my local machine. Dot indicates current working directory. Okay, or you are doing anything in any other folder, you can give the folder structure as well. Okay, I'm using dot because I want to clone it to my current working directory. Okay, now we'll see if I have all the files. Okay, this is how people clone. As a DevOps engineer or SAM engineer, your responsibility is to create centralized repository, okay, and you will give this URL, this cloned URL, sorry, this URL to your team. Then that guy will do this command git clone and this URL and directory where he wants to pull that data, and he will get all the files. He will do the same stuff again and again. If you see git branch, he has master branch. Okay, if you want to give any slave branch, you can give slave branch as well. Okay, here it comes. If it is slave branch, for example, if you have multiple branches, you will give branch name here. Any branch. For example, if you committed, if you pushed your slave one branch, you can give the URL like this so that he will pull the slave branch to here. For example, here we already have something like this, right? Git slave one. Yeah, it works only for centralized repositories. Okay, so this is how you have to push and pull these things. Do you have any doubts up to here? So what I'm saying is, first, as a SM engineer, you will set up centralized repository and people will push their code to centralized repository. Okay, you will not do anything, seriously, at a coding point of view. So what you have to do is, you have to, after creating centralized repository, if anyone asks you for URL for cloning, you have to give URL and you have to create username as well. If you have centralized repository, the push command or pull command or clone command will look like this. User is j at the rate some IP like 192.32.168. For example, 1.2 colon slash any location branch name. Okay, and their working directory, for example, j. So like this, the command will show up. Okay. After hitting this, it will ask the user for the SSH login, so that he has to enter his password to connect to the repository and clone. Okay. He will get enter repository onto his local machine, and he will start working on that code, and he will do the same stuff, committing, pulling, pushing. But remember that whenever you add a file, it doesn't mean that it is already in Git. Whenever you create a file, it doesn't mean that it is added to Git. You have to use your add command to add it, and it will be in staging area. Okay, there you have to commit it. Whenever you commit the code, your code will be committed to your local repository, but not the centralized repository. In order to place your code in centralized repository, you have to use your push command. Then only it will be in your centralized repository. Until then, it will be saved in your local repository. Okay, these things should be more clear to you, so that once it is done, you will go to interviews, and in interviews these questions will be very important. So do practice that. Tomorrow we will not have any classes, but tomorrow will be practice session for SVN and Git. So I want everyone be ready for one Linux and Windows machines. If you don't have both installed on your machine, I suggest you to install VirtualBox today. And tomorrow, if you I'll give you a few tasks, and if you stuck anywhere, I'll remotely connect to your machines and let you know how to fix that. Is that clear? So be ready with virtual machines. You need to have one Windows machine to install Visual SVN and Tortoise, and one Linux machine for Git. Okay. So tomorrow you will do all this stuff, and I'll share your screen if you have any doubts, so that other people will learn how to fix those issues. Okay. If you have any doubt up to now, please ask me.